first we open the tire, open all the hub screw.
Next, the drain pan is put under the car to avoid the brake fluid spilling on the floor.
Okay, so now we're gonna open the bleeding nut and bleeding and brake hose. Yes.
Open the two screw at the back of the caliper.
Then the screw is taken off to split the support bracket and the caliper body. Next, the brake pads are taken out from the caliper.
The brake pad clip.
To take out the piston, we have to tighten back the bleeding screw, then the air gun is put at the hole's brake hole. By using the vernier caliper, the thickness of the brake pads are measured.
The reading we got is 7.13, and we take another reading. And it shows 7.71 mm. Final reading, take from here, 7.88 millimeter. So measure the backplate of this brake pad. So as you can see, the reading is 5.11. So the first reading is 5.11 and the second reading is 5.41, and the third reading is 5.13.
Okay.
So as you can see, the brake pad is rusty and the thickness of the brake pads can be used.
To check the condition of the disc, we chop the disc brake surface. Yeah, boy. And then we take the brake pad and rub against the surface. Now we check the surface of the brake pad. Okay, we can see that some part are not touching this brake, the disc, as they are not what we say, no sign of chop that we rub against the disc. So it's either the brake pad is not in good condition or the disc is not really smooth. Yeah. And we repeat the same process at the back of this brake. Mostly touch the brake pad, but there's still some spot that doesn't touch the disc. So yeah, the same explanation might be the disc is not really smooth or the brake pad is not even. The surface of the brake pad is not even. So yeah, the position of the piston is still in a good condition. There is no crack, so it is still can be used again for future use.
Satu, dua, tiga.
So we are going to test whether these screws are in a good condition or not. So we're going to test like this. And this one. If it's circled in a good, if it looks in a good circle, it means that these screws are in a good condition. So these both are in a good condition.
Now we need to measure the thickness of the disc at different places. 10.31 After we have chucked the pipe, we need to clean it back before we refitting it.
Okay, so now we're gonna put it back. Pasang balik lah.
Assalamualaikum and good day. My name is DANIAL bin Hidizani. Today I'm going to explain Lab 4 disc brake inspection, removal and refitting. So for my group members, me myself, DANIAL bin Hidizani, NOOR NAJIHA, ARMAN KUSHAIRY, IKRAM and ZARIF IKRAM. So for procedure and the work process for this lab, we have explained the work process and the procedure during the previous video. So for discipline and safety regulations, the first one, always wear lab jackets, safety shoes and other protective equipment during the lab session. Next, put the tires under the car. Next, cover all body parts and be careful not to spill brake fluid during lab. Next, stay careful when disassembly all the parts, especially the heavy parts of the car. Then, place all the nuts at suitable place to avoid any missing nuts. Next, use the right tools to avoid any harm or even damage to the part. And the last one is make sure the car has been properly supported when taking off the wheels.
My name is ARMAN KUSHAIRY bin Aswandi and my metric number is B0920100405, and today I'm going to explain about the result and outcome for this lab. So for the table 1, we can see that number 1 is lock pin, number 2 is guide pin, and number 3 is pin center bushing, and number 4 is mounting bracket, number 5 is guide pin boots, and number 6 is piston seal, number 7 is piston boot, number 8 is brake piston cylinder, number 9 is piston oil seal, number 10 is brake lining, and number 11 is brake pad, while number 12 is back plate of brake pad, number 13 is shims, and number 14 are brake pad clip. So for table 2, condition of this brake part. So for number 1 is the wear indicator, which is the wear indicator still can be used and in good condition. And number 2, disc brake surface. The disc brake surfaces are rusty and in good condition, still can be used again and might need it to be skimmed a bit to get the surface to be even. So for the number 3 is the outboard brake shoe, which is the back plate. The thickness the brake pad back plate is still can be used again, as it is still thick and didn't wear out yet. The condition is a bit rusty but still can be used. So for number 4, the inboard brake shoe, which is the brake pad itself. The thickness is the brake pad still can be used, as the brake pad is still thick enough to be used again. The condition is still good. For the number 5, piston, the piston cylinder is still in a good condition, no crack or scratch mark on the piston body and still can be used again. For number 6 and the last is the cylinder bore. The cylinder bore is also in a good condition, which there's no sign of crack and also no leakage were found during the deassembly of the part.
The inspection of this disc brake condition, the run-out measurement. The run-out measurement of the brake disc should not exceed 0.07 mm. Have grooves which might need it to be skimmed to have even surface through the entire of the surface to give better brake performance. And for the disc thickness measurement, the first one is 10.31 mm, the second one is 10.25, the third one is 10.35, and the fourth is 10.6, and the fifth is the 10.56. As we can see, the measurement thickness of the brake discs were not the same throughout the circumference of the brake disc. Thus, the measurement were not that too far from each reading, but the run-out measurement were seen. Thus, this can make damage to the entire braking system and also cause vibrations, and might need it to be skimmed through to make even throughout the disc, to make an even surface throughout the disc brake. And the rub test, or also the rub test, were not as successful as it should be. It might be the reason behind of it, because the force that been given by our hand to make the chalk mark onto the brake pad are not as hard, as strong as the force has been given by the brake piston. Thus, this can be said that the rub test will fail. And the guide pin or lock pin straightness, as the test that we have done, the guide pin and the lock pin was still straight, which when the tests were being done on the floor, the pin were moving and turning in kind of a perfect circle, so it can still be used. Based on our finding, the condition of the brake pad is a bit rusty. It should be replaced with a new one to prevent such issue. Worn out disc brake or pad may significantly affect the efficiency of the disc brake system. Once the brake pad have become severely rusted and reached the limit, the grinding noise might occur coming from the wheels and will also reduce the ability of the brake to stop. And however, if there is only few rust on the brake pad, there is no need to replace the brake pads. Rust is caused by moisture penetrating the brake over time, but with regular driving, surface rust will be cleaned off by contact with the brake pads during frequent driving.
My name is Lee Hang, number metric B0920102881. So for the next slide, literally run out or uneven clamping forces are one of the causes of this thickness variation. Lateral run out is a condition where the rotor doesn't sit perfectly parallel to the wheel hub, so that causes the rotor to rotate in a wobble pattern. So lateral run out can be corrected by machining with an unvehicle brake later or by installing lateral run out shims. Rotor run out causes the rotor to shudder and can be felt through the steering wheel. It is a condition where the rotor of an engine does not spin as it should. So there are irregularities or gaps in the metal finish on the motor itself.
The correct procedure to repair thickness variation is as follows. First, remove the tire by loosening the nuts and raising up the car for better access to the rotor. Second, place the tire under the car for safety. Third, by using a vernier caliper, measure the thickness of the rotor. Fourth, use dial gauge to measure the run out in the rotor and hub assembly. Check the amount of run out in the rotor and hub using dial indicator both before and after rotors has been machined. Fifth, reassemble the wheel and use manufacturer's specification of torques on the bolts and the nuts. And the last one is test the vehicle.
Hi, Assalamualaikum. My name is NAJIHA binti Justifa Zumanin with metric number B0920100096. So I will explain about the discussion of question 3 and question 4. So for the question 3, what do you understand about run out measurement data? Brake disc run out, which is defined as a variation in the distance of a brake surface to a reference plane, is a key contributor to torque variations. Run out also leads to disc thickness variation by inducing uneven wear of the disc, and is affected by assembly and manufacturing inconsistencies. As the uneven wear of the disc happen, this judo might be happen and caused by the vibration that it makes during brake being applied. Essentially, the amount of wobble in one portion feature when compared to another, which any feature that rotates around and axis can be called out for run out on its surface. So for the next question is question 4. What is your finding for the guide pin or lock pin straightness check? What can happen to your disc brake system if the guide pin and lock pin is not straight? Based on our test and finding for the guide pin and lock pin straightness check, it was in a good working order. A circular motion test is used to verify this. When a force was applied to the guide pin for a circular motion on a ground surface, we would never stop on while rotating it. If guide pin or lock pin is not straight, the caliper won't move. It could be due to bent or stuck guide pins. If the guiding pins are straight, you'll hear noises or have trouble stopping. When driving, the brakes may become stuck. This also due to the lack of free play for the brake pad to grip and release when the contact made with the brake disc, and due to the jam brake, it may make the brake pad to continue make contact with the brake disc, and this can cause heat, which will jam the brake and makes the car couldn't move. That's all. Thank you.
So in summary, we can conclude that this lab enriched us with the knowledge and skills on handling the brake system. Conducting this lab experiment with proper procedure helps us understanding the mechanism of the brake disc and gives us the solution of any possible problem that might occur of the brake system. The ability to identify the solution of the noise or any unpleasant problem can help us to perform and utilize this knowledge on our daily life while handling the car.